Ooh, a bit warm, isn't it? And the window's already open.
Yeah.
I think there's a storm approaching tonight. I think this is the reason why it's a bit warmer. So it should rain very heavy tonight. Once it's when you're asleep, it's okay. It's only when you have to come to school and it's raining, it's a problem. Okay guys, listen up now, we're starting. Guys, so what we're going to have a look at now, the next lesson is what we call degree 2 systems. So let's have a look at the idea behind this. So in the lessons last week, we were talking about equation of a line, parallel and perpendicular lines. So what we're going to be looking at in the first class today is when we have two lines, we'd like to find out where the two lines meet. I mean, this is fairly normal stuff from middle school and high school maths, but I suppose the main thing we're going to be doing in this lesson is looking at the different methods we have for finding this point. So what I'll do is I'll do 4 examples, maybe 5, and in each example it will show each of the different methods. Just be careful in the exam, because sometimes in the exam they actually tell you which method they want you to use. Okay, so the question might say use the elimination method, and if you don't use that method, I'm afraid you don't get any marks. Okay, so you should really learn these words. So let's have a look at the first method. So the first method is what we call graphical method, and this is one of the methods you could get asked to do in the exam, but to be honest, it's very, very rare that they actually want this method. I mean, I'd only give it a 5% chance of being in your exam, but technically it could be there. So you could probably guess from the name, what's the key approach to this one? Drawing the graph. Yeah, just drawing the graph and figuring out where they meet on the graph. So let's take an example here. Do you want to write this down? So for example, let's say we have y equals, let's pick something kind of nice. 6x minus 3 and y equals minus 2x plus 5. Now we learned how to draw this graph last time, so let me do my very best to make it as neat as I can. Right, so I can see this one crosses at minus 3, so I need to at least go down 1, 2, 3 to here, and it has a slope of 6, which means when I go out 1, I go up 6 units. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. Of course, you can do this much neater than I can. And let's just mark off here. Oh, I don't know if I have enough space here, but we'll try. 1, 2, and 3 there. And I think I'll go up in 2s to make a bit more space. So that will be 2, 4, no, maybe 3s. 3, 6, 9, 12. 3, 6, 9 there. And this is 1, 2, 3. Oh, ugly. Right. Alright, let's get the first one in. So, start at minus 3 and a slope of 6. So that means I go out 1 and I go up 6 units, so I'm finished there. So that's my first line. Right, minus 2. Minus 2. Go out 1. Up. Somewhere in here. So I can't do this without graph paper, but you can do a much nicer job. I would guess the answer is somewhere around about 1, 3, possibly. So this is what we get. in the exam, they're a little bit flexible, okay? There's like a small margin of error. This is more important in your exams for biology, physics and chemistry, where it's more common that they ask you to make a graph and ask you to read off the graph. They usually allow a small error in the reading. It'd be the same for maths as well. So anyways, that's a graphical method. That's not really an exam method. We'll look on to the next method, which is called the substitution method, which is much more exam related. Okay, so substitution method. So let's take something like y equals 9x plus 3 and y equals 4x plus 8. Okay, so if you look at the name here, substitution, does anyone have any ideas on what they think this method might involve? Yeah?
Plug in y and x to find? Or?
Yeah, so you tell me what I should do first here for this one.
I think you can equate them to each other.
You can equate them, yeah.
4x plus 8 equals
9x plus 3, yeah. Which is the same thing as plugging in here. So you realize that this is the same as y. And you have a y here. So therefore, this has to be the same as that one, obviously. If this is y, then you're allowed to replace this with this, or vice versa. So you can easily just pop that guy in there for y. And you get 9x plus 3 equals 4x plus 8. Well, this isn't so bad. You just have to take the 4x over to the left, the 3 over to the right. You get 9x minus 4x is 5x. 8 minus 3 is 5. So obviously here, x is 1. But how can you get the y? Well, that's not so difficult. You just substitute this value back into one of the two equations at the start. So let's just put it into this guy. Y equals 4 times 1, which is 4, plus 8, which is 12. So y equals 12 then. Okay? So write this method down. This method works really well when they're both equal to y, because then you can just say they're equal to each other. Okay, so write this method down. We'll go on to the next method now in a moment. We got this?
So that would be the intersect point, the x and y?
Yeah. Okay. Next method. And the next method is the one I think you all use from high school, the elimination method. I really think this is the one everybody's more familiar with. So method 3, elimination. So let's take an example. Let's say 6x minus y equals minus 9 and 8x minus no, that one's 2. Doesn't matter. I'll do 2 of these ones. Okay. So elimination method works very nicely when either your x's or y's are the same in each equation. So obviously they're different here, 6x and 8x, and obviously they're the same here, minus y and minus y, and this is good because it means you can cancel the y. So it's the same here and here. So what you can do when that happens, add them or subtract them. You're allowed to do either. So technically I'll subtract them because I want them to cancel. You can add or subtract them. So, and not only can you add or subtract them, you can choose which way around to do it. So you could do the first equation minus the second equation, or the second equation minus the first equation. It doesn't matter which way around. Which do you think I should choose here? First minus second or second minus first? Yeah, second minus first, because then I'll get 8x minus 6x, which is 2x, which is nice. They cancel, and 9 minus 9. 18, yeah. So then x is 9. Now I still have to get my y, so I do that by subbing the value in. I'll choose, I don't know, I'll choose the first one. So now I have 6 times 9 minus y equals minus 9. Isn't that right?
Yeah.
54 minus y equals minus 9. So 54 plus 9 equals y. So y equals 63. Is that right, Joe? Alright, so that's the elimination method. Now that's an easy example, and the reason I say it's easy is because they're already ready to be cancelled. I'll do another example where it's not as easy as this. So if you can write this one down, we'll have a look at another one now.
Sorry,
Yeah.
the example that we did specific on the fact that we have to use the elimination method.
Yeah.
Would they use
Oh yeah. They will. Now not always. Sometimes they'll just say solve. Fine, whatever way you want. But sometimes they will say solve by using the blank method, whatever that might be. Okay? Question? Guys? Question? Yeah. Don't be shy. No, don't be shy. What's your question?
I'm confused because I have a question.
Alright. Another example will help?
Yeah.
Yeah, go on. Shh, be quiet, I can't hear.
What about the y sign? Should be the same or the opposite?
Now you see, it depends on your maths teacher from high school.
Yeah.
So, a lot of maths teachers say very strongly the signs have to be opposite,
Yeah.
correct? Yes. But I'm more flexible. They can be opposite or the same. The only difference is what you do to them. So, if they're opposite, which is what you're expected, like 2x and minus 2x, then you're happy. You just add them together and you get 0x. But if they're the same, that's still okay because you can minus the two of them and you'll get 0x. So you have the flexibility of adding and subtracting, but your teacher made it seem like you can only add, and you can only add when they're opposite. But it's a bit more flexible than that, actually. If you prefer to make them opposite and add them, that's fine. That's fine.
So do we always subtract in your way?
No, either. You can add or subtract, depending on which way the signs are.
You have to
Yeah.
multiply one equation by like minus.
Yeah.
Yeah.
But it's very important to know this about me. I'm lazy. And if I can skip a step, I'll skip a step. So the step I skipped here was multiplying by minus 1 to make them opposite signs, yeah. But why do more work when you can do less work? Think about that. Right. Next one. Minus 7x minus 9y equals 1. Minus x minus 2y equals 8. Alright, so this one's a little bit different because nothing is the same. But with not too much effort, we can actually make the x's the same. It looks like, yeah.
Multiply by 7.
Yeah, if we just multiply this line by 7, then we're happy. We'll get minus 7x minus 9y equals 1, and minus 7x minus 14y, what's that, 58, is it? 56. Isn't it? 7?
No, it's 54. No, what? 54. Hold on.
Could you settle this debate, please?
No, the 9. 56.
56.
What? 63.
8 times? This is right?
No.
Yeah, this is right.
This is right. What's wrong with these guys? Yeah, 56, yeah. Yeah, they don't let you graduate Trinity College without knowing this, okay? They take your degree back. Right, so what should I do here? Should I add or subtract? Subtract. First minus second or second minus first? It's a little bit easier one way than the other. First minus second's a little bit easier. Because these two cancel, And then you have minus 9 minus minus 14, which is a plus, yeah, 5y. And then 1 minus 56 is minus 55. And then I think we can all see what the y is. It's, let me write down here, y equals minus 11. Yep. Okay, now that we have the y, we'll sub it back in. Now, actually, it doesn't matter which one I sub it in, but there's actually an easiest equation to pick here. Which one looks like the easiest one?
The minus x minus y.
Yeah, it looks like it'd be a little bit easier to use this one, doesn't it? So, we get minus x minus 2y equals 8. So I get minus x plus 22 equals 8. So I get 22 minus 8 equals x. It's 14, isn't it? Yeah. So I get here x equals 14. Alright, so there's another elimination one here. This is more typical of the exam then. Okay, so write this one down and then we'll have a look at another method. Okay, you got that written down? Yeah? Alright, next method now. Now, there was that 1, 2, 3, 4. There was previously 5 methods, but there's only 4 now. The other method that we don't do, some of you might have done already, matrix method. You know of it. Yeah. Anyways, we don't cover that method, but we do cover this method.
Oh yeah.
Rows, columns, inverse, the whole thing, yeah. 2 by 2, 3 by 3, all that stuff. Now, this method here, I suspect is a method that most people haven't seen before. So you'll have to watch carefully for this one, okay? Because I think this will be new for pretty much everybody. Yeah? Listen. So, I'll do a simple example. In fact, what I'll do is I'll do this one again, but a different method. So minus, if you can just read it back to me, what was it? Minus 7x.
Minus 9y.
Yeah.
Equals 1. Minus x.
Yeah.
Minus 2y.
Yeah.
Equals 8.
Okay, so let's have a look at this method here. Now, if you've studied the matrix method before, it looks like the matrix method. It's not actually the matrix method, it's something different, but the way you write it down, it looks familiar. So don't mix it up with the matrix method. We don't do that method, it just looks a little bit like it. So this is how the Gaussian method works. Rather than writing x and y repeatedly, you write your equations in a block like this. So this number here represents the x, this represents the y's, and this dotted line here represents the equals. This represents the x, the y equals 8. So the first thing you do is you change this into that form. Now we haven't really done anything yet. We've just written it in a nice, neat block. That's all we've done. Can you see how the numbers correspond? Minus 7 is that one, minus 9 is that one, and 1 is there, minus 1 is that, minus 2 is that, and 8 is that. So they match up. Okay, so here's the deal. You are allowed to multiply, add, and subtract. So you can multiply any row by any number except 0. So I could multiply this by 2, multiply it by 3, whatever. And you're allowed to add rows together and put the answer on either row. So for example, you could do row 1 plus row 2 and write the answer on row 1. Or you could do row 1 plus row 2 and write the answer on row 2. So you got two basic rules. You can multiply by any non-zero number, and and you can add rows together and put the answer on either row. Now I'll show you what that means now with this one. So what I'll do is I will multiply this by minus 7, the second row. So now I get minus 7, minus 9, 1, 7, 14, and what did we say? 56, didn't we? Minus, correct? Yeah. And you say, okay, that's great, because these are the opposites. So what I'll do next is I'll say row 1 plus row 2, and I'll put the answer on row 2. So the first row is unchanged. I'm not doing anything to it. But the second row is changed, because what I'm going to do is say row 1 plus row 2 and put the answer on 2. So minus 7 plus 7, 0. Minus 9 plus 14 is 5. And 1 minus 56, minus 55. Now here you're actually done, because if you change this back, what do we have? We have, let me squeeze it up here, I have minus 7x minus 9y equals 1, and here I have 5y equals minus 55. Now why is that finished? Well, can I easily get y here? Yeah. And then once I get y, then I can get x then. So this process changes the equations into simpler equations. Now you might think that's not very useful because it seems like a lot of work, but it works really, really well when you have more than 2. So I'll show you what happens now if you have 3. Because if you have x, y, z, this method is a very quick way to simplifying your equations into something very, very useful. Yeah, go on.
So you're trying to make one of the variables equal to 0?
Yeah, in fact, more precise than that. You are targeting this guy here, and you're making that 0. We'll do 3 in a moment, and when we look at 3, our goal is
0, 0.
yeah, we want number, 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 0, number, number, 0, 0, number, yeah. You've seen this one? Yeah, great. So you're trying to get a triangle of zeros. This is the goal. Now write this one down, and we'll do another example, don't worry. So just write this one down here. Obviously I'm not going to continue here because this part now is easy now.
Confusing when you have 3.
Maybe it won't be as bad as you think. It's certainly more confusing than 2.
Yeah.
So how many people have seen this method before? We have 1, 2 up the front. Oh, good, okay. So can you do it with 3? Easy peasy?
We can try.
Can I scroll down? Yep, okay. Scroll down? Yep, okay. Let's have a look at 3. Okay. Right. Let's say x plus y plus z equals 3. Let's say 2x plus 3y plus 2z 7. And let's say 3x minus 2y minus z. I don't know. Let's say that's 0. Okay, let's try this one now. So step 1, we write it in a block. Okay? So our block looks like this. 1, 2, 3, 1, 3, minus 2, 1, 2, minus 1, equals 3, 7, and 0. Now, multiplying time. So, I'll go with 6 minus 3 and minus 2. Let's see what we get. So, firstly, I'll have, oh, exciting, 666, and then 18, minus 6, minus 9, minus 6, yeah, minus 21. I made this too easy. Alright, doesn't matter. Minus 6, 4, 2, and 0. But I think I'm going to change this because I made this a little too easy and I want to make it a bit harder. So I'll just put it in red. Just make a 2 here. So this will become a 2. Oh, and so this becomes a 4. So this one becomes a 4. So this one here now is 12. And 4 times 6, that's 24. Okay, no, the reason I did that is I wanted to make it a little bit harder because I didn't want your first example to be too easy. Right. So now time to add the rows together. So I'll do row 1 plus row 2. And where should I put the answer? On row 1 or row 2? What do you think? Yeah, row 2. And I'll also do row 1 plus row 3. And where do I put that answer? Row 3. The reason for doing that is these two numbers here will become 0. Watch. The first row is the same. Why is it the same? Well, nothing's changing on it. But the second and third row are different now. The second row is going to be whatever row 1 plus row 2 is. Right, 6 and minus 6? 0. Minus 3? 6 and 3. Is that right?
Yeah.
Looks okay. And then row 1 plus row 3? Put the answer on 3. 6 and minus 6? 0. 6 and 4? 10. 12 and 2? 14. And 24 and 0? 24. Okay, we're actually not doing so bad because you realise you have your 2 zeros here. So which number in this block do we want to try and make a 0? The 10. So we have to target the 10. So what I'll do, I shall multiply this by 10 and this by 3. So now I get 6, 6, 12, 24, 0, minus 30, 60 and 30, 0, 30, 42, and 72. Alright, what should be my next operation? Row 2 plus row 3, answer on row 3. Right, let's see what happens now. So I get 6, 6, 12, 24. 0 minus 30, 60, 30. Now, row 2 plus 3. 0 and 0, 0. Minus 30 and 30, 0. 6 and 42, 102. Yeah? 72 and 30, 102. Isn't it? Yeah. Now, we're finished. Because look at what we've done. We now have this equation. 6x plus 6y plus 12z equals 24. Minus 30y plus 60z equals 30. 102z equals 102z. What does this last equation give me? What could I figure out from this last one? I could easily get it, couldn't I? What is it equal to? 1. Yeah? Can you see that, right?
Yeah,
102z equals 100. Oh, sorry, I didn't mean to write z again. Sorry. 102. Ah, now it makes sense. Alright. Is that okay? Now, If I know z, what can this equation give me?
Y.
Yeah, because I can take this, sub it in, and I can get y. So if I put in z is 1 and I solve this, I know I'll get y is 1. Okay, so I know z and y. If I take these two and sub it into the top one, what can I get? X, because I know y and z. And when you sub it in, you'll end up solving, and in fact you'll get x is 1 then for this one. So this method here, let's see, 1, 2, 3, in 4 steps, you can turn this system into this system. And there's a huge difference. It's much easier to solve this, right, than it is to solve this. Because this one it's nearly solved. This easily gives us z, this easily gives us y, and this easily gives us x. Easy peasy. So we transform from here to here in 4 steps. Okay? So this method here works really well when you have more than 2. So there's no point in using this for 2, and they'll never ask you to use this for 2. 3 is the minimum before you can think about using this method. So for semester 1, I don't think they ever give you 3 in the semester 1 exam. I've only ever seen 3 in the semester 2 exam. So for semester 1, don't worry about this method so much. It's more relevant for the final exam. In semester 1 exam, they only really ask for elimination and substitution. Okay? So don't freak out if you're not happy with this method. Yeah?
Is there an easier way to find what you multiply with? Like, I noticed you multiply with 6, 3, 2 instantly because there. For what reason?
I need to think of the smallest number in my head that I can multiply these numbers up into.
Okay.
You can solve them to 2 equations.
For these 3? What do you mean? You mean like for finding these numbers, or?
You know, by finding them and...
Oh yeah, I mean there's another way to do it where you can take the 3 equations and then separate out 2 equations from each. Yeah. So that's kind of like the elimination method, but you split it into 2. Yeah. That's fine too. In fact, we kind of use that method more in physics class. If you want to do it that way, you can. Because of course the elimination method and the substitution method, they work for x, y, z as well. So if you want to use elimination or substitution, you can. You can't use graphical method for x, y, z because that's 3 dimensions, which is hard to draw. Yeah, it's a little bit hard to draw 3 dimensions in your notebook, but you can use the other 2 methods.
So you're just multiplying to find the smallest multiplication to equate.
Yeah, you're looking for the smallest multiple of the 3 numbers. So like here, 3 and 10, any smallest number I can multiply them up into is 30. I can't think of any number that 3 and 10 both multiply up to, you know. Yeah. It's just a multiplication thing.
Yeah.
Anything else with this method? Can we write this down, please? Okay. Now I write my answers like x equals y equals z equals, but you know, if you want, you can write because it's a point, you could write your answer like, for example, here you could have written your answer as 14 minus 11. It's fine. Now you have to be careful because maybe they actually care about how you write your answer. You know, you could say x equals 1, y equals 2, or you could say 1, 2. What word would be in the question if they want you to write the answer like this? Yeah, find the coordinates or find the point. Yeah. Well, actually, I guess you could say that is the same thing. But really, if somebody said coordinates, you kind of want to be writing it like this, I think. It's usual, isn't it? Anyway, I don't think they're that fussy in the exam. A very common, not very common, but a mistake that students sometimes make which is kind of a sad mistake, is they would find the x, and then they would forget to find the y, which is very sad because they're nearly finished and they just forgot to do the last thing. So don't forget to do that, please. Okay, so what we'll do now is I'll give you 10 minutes to practice some of these, and then we'll start the next lesson. So if you can just circle these questions. In number 1, yeah, if you do the first and the last. So in number 1, do A and E. In number 2, do A and U. In number 3, do A and X. And number 4, do A and E. Yeah, it's the first and the last in each question. So 1 is AE, 2 is AU, 3 is AX, and 4 is AE. You got that? Yeah. And listen carefully, please. Listen. 1, 2, 3, 4, 5, 6. I've given you 8 questions there. Okay. Whatever you get done now, that's great. If you get all 8 done, that's great. But I want those 8 finished for your homework. Okay. So just those 8. Yes. And I'd like to check. Actually, while you're working on that, I'd like to check the homework there. Can I close this? No? Okay. And can you just take out your homework while you're working on that? I want to have a look. Now, just to make a confession, I normally give about 8 to 20 questions per homework, not 100 or 200 questions. The only reason I asked you to do that many on Friday is I wanted to see who would. So I'm going to find out now who's willing to follow my instructions regardless of how crazy they seem. That is what I was trying to achieve. So I'll find out now. Right, so did you blindly follow my instructions as you all go? Yeah, right. Are there any problems? Oh no, there's just the one problem, wasn't there?
No, page 1, page 2.
Yeah, no, I mean, you only have the one question.
Yeah, the only
What's this
7
one
and
here?
5. I didn't.
Oh, and a bit of 5 as well.
Yeah.
Okay, well do though, just make sure you circle them or something so you can remember to ask me in the tutorial then.
Well, I have some idea of it, but I'm not sure. That's why I didn't do them. So.
Oh yeah, no, okay, yeah. Those are tricky ones. Yeah? Yeah, when I get around you can have a look. So, homework.
Over here, I did almost all of it. I had a few issues. There are a few questions while graphing them.
Yeah.
They don't align.
Yeah, well that's, have you got a ruler?
Yeah.
That's how you keep them.
Because regardless of this, there is a graphing software.
Oh, you know,
Well,
don't worry about
graph-
graph. Don't worry about graph. You can't get graph paper.
So some of this is page 1. This is page 1 over 1.
Yeah.
Then I have nothing, and there's
Yeah.
4. Then I tried doing it all in one graph. It was a mess.
Beautiful.
It was horrible. So I tried to do each one alone.
Okay, that's grand. And where's the next question then? Oh, this is the parallel and perpendicular.
Yeah, the parallel. The perpendicular, I had an issue with them while solving them. While trying to graph them, they weren't giving me 90 angles.
I don't worry about the graph, to be honest, because it's a standard graph.
Yeah, and 6 and 7.
Yeah,
they make
he
no
was
sense.
mentioning those, we'll probably do those in the tutorial. How'd you do?
Really messy.
No, don't worry about that.
Getting a separate version.
Oh yeah, no problem. No problem. So this is almost You're a medical student. With handwriting like that would be a doctor, no problem. Yeah, that's always the joke here about doctors.
My handwriting is so bad.
But this is good, and you're keeping all your maths in this notebook.
Yeah, I'm thinking of doing a separate one.
Do you think so?
So you think
you would prefer to get the homework separate to your classwork. Some students do that, but to be honest, and it's your personal choice, you know. I don't really see it as a big need. It's if you want to keep, I would want to keep all my maths together because, you know, if you lost one notebook, then you know, whatever works best for you. Like how you do on your homework.
Separating. This is right. My notes.
Wonderful.
This is my transcript. That way, I have more. Anything else, I'll get confused.
I just have all one. Go.
Nice. Any problems? Anything easy? Oh, good. Okay. Okay. So no trouble. Wonderful. Wonderful. Right. How did you do? Yes. Nice. Nice. Any problems?
Just number 7.
Yeah, I think someone else said that. So we'll do that one in the tutorial there. Just remember to ask that. Right, Harold, did you get on?
Let me see now. There were questions that I have to take. Just wanted to where are the 6 ones? Yeah, A and B. I can go by that.
Yeah. Graphics are useful. Nice, okay. Did you have any major trouble?
Well, I didn't get to the number 7 and talk about.
Yeah, everybody seems to be good.
Can you show me D of number 1 if you have it?
Okay, so how do you
D of number 1 if you have it. Page 4, yeah.
Very good job. Are you keeping your homework separate, is it? Oh, great. You have the folder to put them in? Good stuff. And you're the same, everything was okay? Wonderful.
Where's the graph? Man, the graph number, it is not even close to each other.
I'm not so worried about that. And for you? Right. Fantastic.
11:26:54.
Okay, how did you do?
7.6? Yeah.
Great.
No, that's 8. No, that's 7.
It's not too easy, not too hard.
Yeah, that's what?
54.
54? 54 is not.
Hold on.
What do you multiply with 54?
It's
5 times 6 or 6 times 9?
Yeah, great, okay. And what's this? Wow. Okay, that's it.
Yeah. I don't know. Just start. Bring up.
Yeah, no wonder.
Okay, how did you do? That's fine.
No wonder I'm putting a screen for
Clear. Where?
That's why I'm in the middle.
Any problems?
Man, first of all, the heater is on. The heater is on.
Okay, and how did you do?
Turn off from like the other screen, like just below really deep stuff.
Yeah,
Man, we're supposed to be
right,
on
how did you do?
It's so warm.
So you can come home. Okay. Yes, I'll get you another tablet. Yeah. How did you do?
Graphical method, did you graph this properly?
Yeah. Yeah.
This one, I can't. I just can't. The one that we saw.
Yeah.
I did. I didn't think it this way, no? I took it as elimination.
There's another way of this called the chosen method method. Actually, it's much harder.
Good. But you're having trouble.
I had a chat and it took 2 pages, 2 full pages.
And did I ask you to draw? You need to draw. Yeah. So you were having trouble how to draw this. No problem. So in the tutorial this week, make sure you ask me to do some more examples of these. I can do some examples in the class, okay? So just make a note to ask that one. Yeah? Is this the only problem? Great, okay. You don't like the graph. You like the other one. I tell you what. Skip this one for now, okay? And start with number 2. And then we'll do some of these in the tutorial. Then after the tutorial, we can try them. Okay? So we'll do that this week. Right, how did you get on? Yeah. Just draw the lines and we can point out. But look, if you're having trouble with that, you can start with this. No big deal. So how's your own going? No problem. You need to be a little bit organized. Yeah, okay, good stuff.
What's 9/197? 1 point. Yeah, 1.29.
Great. And do you have any trouble with these questions? Just the graphs?
So is your brain?
Now it's important that you make note of the ones you have trouble with so we can do them in the tutorial.
Intersecting?
Oh, very good. Okay, good. So yeah. Yeah, that's what the students behind me want to see more of. So we'll do these in the tutorial, okay? Good stuff. Rearrange. Yeah.
The nice thing is, some questions I will get give me the, if you wanted to graph the
All right.
there was no
Take a couple of them to the tutorial and ask me to do them then this week. So. Yeah, that's fine. That's all good. We can do them in the tutorial. How'd you get on? So this is a linear equation, yeah? No trouble? Oh. This one here? No problem. Just play around with it. We can do some of them in the tutorial. No problem. So everything else is okay? Great. Yeah. Yeah, as you heard, he was having some trouble with these as well. So again, we can do some of these in the tutorial. Just mark one or two to pick at random.
You want me to graph this? Yeah.
And I don't think I need to solve this one. So with that, I think the tutorial.
Even on graphic software.
Okay, good job, good job. Yeah. Yeah. I think yeah, will be strong. Yeah.
I just plugged in.
What's that?
This is the graphic method. Graphic.
Second? Oh, get it very carefully. Drawing a very cute graph.
Can I throw it out the window?
It works.
I know, you can do this as well.
Look. Now, this is the first one.
But I do have
Let me see what I will say.
find out where the line crosses the x and the y axis and draw the line at those points.
Minus 8x.
Do you know how to get the x and the y intercept?
How what is it?
So to get the y intercept, we make x is 0 and
I graphed it.
if you find 2 points and draw a line nice and straight between them then. Question? I'll get to you in a sec then. Right, how did the homework go? I don't have your complete obedience yet. That is okay. I'll have to work harder. So, of the ones you did then, did you have any trouble? Oh, great. So, no problems then?
Yeah.
No. Wonderful, wonderful. And for you? Not hard enough, huh? So what did you say number 3? In this one? Yeah. Yeah, no problem. So you probably want to do some more in the tutorial. So just mark the one to ask you to do and do more in the tutorial. Just mark whichever one to do in the tutorial.
One doesn't disappear.
Yeah, but like,
It just keeps going.
where does it
Right,
intersect?
how do you get on that number there?
Okay, let's just.
I think it's good.
But come on.
60, 90, 100.
This one, that's the problem. It's not easy. Oh, okay. And how did you get on? Yeah.
Somewhere here.
Oh, okay. So you don't need any. Okay, no problem. So you don't need any. You don't need the tutorial for you. Okay, so how did you get on? Wonderful, wonderful. Now, so you have to have the tutorial. Yeah. Yeah, which one of the tutorial? Yeah, number 9. Oh, yeah, that's question mark.
Y is 0. So you take 8 to the other side, it's going to be minus 8. Minus 8 divided by minus 6. It's going to be 8 over 6.
7 as well.
You get that one.
Yeah.
Yeah.
What do we get? That's the right answer. We get the right answer at the end.
First, you go to the right one.
Good, okay.
Yeah.
Yeah? Okay, good, okay. Yeah, that's good, good, good.
Okay,
Yeah.
I'm calculating.
Another way, what is that?
Yeah.
Yeah, that's what I think it will.
Any class of minus 6 minus 6
No, just do the opposite.
we knew that.
Technically, a line is parallel to itself because they have the same slope. But technically, it's parallel because they have the same slope. But it's not the same slope in the same line. When you're thinking parallel, it must mean there's just a distance between them. In fact, it just means that the slopes are the same. It's technically true.
Just the line.
These are both lines though. So you want me to remove the second one? Yeah, because they're over each other. So you understand.
Yeah, I know. I drew the